Geometry, Chapter 1, Section 2, Linear Measure. Last section we talked about lines, which go for an infinite length in both directions. A line segment is, imagine it's chopped off. Like we talked about, the pencil before can represent a line if you were to extend it out forever. But most pencils, they have a specific length to them. And that specific length is a line segment. So, because it's chopped off, we can measure it in some way. Whatever units of measure you happen to be using, millimeters, inches, feet. I mean, technically you could measure this pencil in miles. It wouldn't be a very nice or useful number. Usually you'd measure it in like inches and then have fractions of an inch with it, maybe millimeters if you want to be really accurate. But the big thing here is it has two endpoints, and that's how we name it. So if we have a line, AB, it is infinitely long. But the line segment just connects those two dots. Right? So it chops off both ends and just says, nope, I just want these little bits between these 2 points. When you are measuring lines, you use rulers of some kind. Either it's going to be a metric ruler, so centimeters and millimeters, or you're going to use a standard, which is inches or in feet. Here we've got, for the first example, lengths using a ruler, and they're in metric units. So if I take a look here, I can see that A is lined up with 0. And if you don't ever line up one of the points with the 0, it's going to make it very difficult to actually measure it. It's not the end of the ruler. No, they got that empty gap. It's where it lines up with 0. And then you can see here that the B falls between the 3 and the 4. Now the question is, how do we approximate these things? Well, ask yourself, is that point B closer to 4 or is it closer to 3? I'm going to say it's closer to 4. So this answer for part A is just going to be 4 centimeters. In part B, the image now has centimeters on it, but also has the little marks between it, which are millimeters, which means we can measure it much more accurately. I can see A is still lined up with a 0 there, and now the B is lined up with, looks like that little spot right there. So there are 10 millimeters in each centimeter, so all I have to do is count out how many of those tick marks I have until I get to it. And it's kind of hard to see on the page. I mean, I'm just counting it with my finger, basically. I guess I can do a little mark for each one that I do. Let me see here. I got 1, 2, 3, 4, 5, 6, 7. So this was 7 of those little tick marks. That means that my answer here is 3.7 centimeters. And you can see that kind of matches up if we talk about rounding. Rounding, you always go, if it's 0.5 or above, you make it the next number up, right? So, or it's 5 or above, you just make it, you take it up. Well, if it's accurately 3.7, if we were to round that number up, because we don't have the millimeters, it would round up to 4. A and B are basically the same line. All right. Example 2. Lengths in standard units, and this is inches. And inches are a little bit more complex. Let's start out here. I've got inches. You can see C is lined up with 0 inches, and then C is lined up with this other marking, or D is lined up with this other marking. So to figure out what fraction of an inch it is, what I do is I count how many of those marks there are, and it looks like it's 1, 2, 3, 4. That means this is one of those fourths. So my answer here is going to be 1 1/4 inch. And if you've ever done any sort of like work with your with anyone about like building anything, this is what's on a tape measure. Now, a 1/4 inch is not bad. It's not super accurate. It's okay if I'm like building a doghouse maybe, but if I'm building something really nice, like a really nice chair I don't want it to be loose at all when people sit on it, I need to make it more accurate. So I look at more tick marks for it, and you can see in problem B that there are more tick marks inside of it. So again, it's 1 inch and then some sort of fraction. Let's count off to see where those fractions are. It's 1, 2, 3, 4 of those parts in, but now I need to figure out how many of those parts there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 1 and 4/16. Now, both of these lines are the same length. 1 1/4 inch is an exact measurement because it lands right on 1 1/4 inch. If you reduce that fraction down 4/16, it is still 1 1/4. But because we measured it at 1/16 of an inch, we are more accurate. It could have been slightly more and been 5/16. And then I would know that, I need to actually cut this at 5/16 instead of just a 1/4 inch. But you do always want to reduce those fractions down, but you're going to want to start out at the place where you see all the different marks in it. There should be, in a lot of the pictures, or a lot of the problems in the book, pictures of rulers underneath them. If not, grab a ruler or tape measure to do things. If you don't have one, you might be able to print one from offline, but it's really hard for me to hand out all of my rulers in online learning for a single lesson. And we're really only doing measurement like this for today.